Welcome to an introduction to vector drawing, the foundation of all the cool tools at Makersmiths. In this part 1 video, we're really going to focus on the difference between vector and raster images, but we'll also talk about how you use those kind of images in your projects and give you some examples of what a vector image looks like depending on which program it's opened in when you're setting it up for a CNC, a vinyl, or a laser cutter project. Most people think of CNC as sharp router bits spinning very fast and cutting wood or metal. CNC actually stands for Computer Numerically Controlled, which actually applies to a lot more Makersmiths tools like the laser cutter, the vinyl cutter, and the plasma cutter. All of these computer numerically controlled tools actually rely on vector graphics to all or some degree. In addition, additive manufacturing processes like 3D printing also utilize vector graphics, albeit in 3 dimensions. And if you want to do large format printing, such as on the plotters at Makersmiths, vector graphics can be used to ensure that your designs don't pixelate, or in other words, get very blurry when you blow them up and make them huge on the plotter. The good news is that the vector drawing class will help you get familiar with these base skills to use any one of these machines. They are all very similar in that you create a design in a vector drawing program first. You then translate that design into a code that the machine understands, which is frequently but not always G-code, with the attributes that each particular machine needs. The machine then executes those commands, either cutting where and how fast you want it to cut in the case of subtractive manufacturing tools like the Big Red CNC or the laser cutter, or moving and extruding layers of plastic in additive manufacturing processes such as 3D printing. Either way, a solid foundation in vector drawing and vector graphics will set you up for success in using many of the coolest tools that Makersmiths has to offer. So, let's start with what a vector image is and how it is different than the raster images most people are used to working with on their computers. A raster image is one that's made up of pixels, or tiny squares, of different colors and different transparencies. Every photograph you've ever taken or used is going to have been a raster image. Taking a picture with your cell phone essentially captures your image as thousands or millions of tiny little pixels. When you're editing a photo, no matter what fancy tools are in your editing program, you are basically just changing the color and the transparency of those pixels one by one or by the hundreds, depending on what kind of tool you're using. Vector images, on the other hand, are very different. They're made up of strokes, which you can think of as lines, that can be curved or straight and have a line thickness and or a color. They're made up of objects, which you can think of as shapes that have a fill color and a transparency. Strokes and objects are defined then by nodes. Nodes are basically where the start and the end of a line are and can be used to define the boundaries of a shape. Nodes and the strokes connecting them to form objects are defined by math equations. You don't need to know the math equations, you just need to understand that rather than editing individual tiny pixels by changing their colors and transparencies and drawing on them like you would with the pencil, marker, or paintbrush tool in your particular program, you actually create vector graphics by drawing the lines and shapes, then moving individual nodes, adjusting curves, and applying fill and stroke colors to get the vector graphic you want, no matter how simple or complex that shape may be. To illustrate the point, on screen you have a stylized horse and the 2 versions of what you'd see if you zoomed into the eye of that horse, one in raster and one in vector. If it's a raster format and you zoom in, it will eventually start to blur and you'll be able to see individual pixels. If it is in vector format and you zoom in, the image stays crisp and clear. All photographs are raster images, no matter how high the resolution or how many megapixels the image is made up of. Here, the letter O is shown, zoomed very far into a high-resolution camera image, so it looks like a bunch of individual pixels. As you zoom out, the picture becomes clearer because you can't see the individual pixels any longer. But if you zoom out far enough, because this is such a high-resolution image, you can't even see the O because it's now too small. You may know that the sign says one way because you recognize the shape of the sign, but you can't really actually make out any of the letters. But no matter how high a resolution the image is, or how many thousands or millions of pixels are used, the image is still just made up of tiny squares. And it would be really hard for a machine to find the line to cut on, engrave on, or extrude material to create a smooth letter O from this image made up of little pixels. Even if the image you have on your screen looks like a smooth O, as long as it's a raster image, it really won't work for most CNC-based projects. So I've spent the last 4 minutes explaining why raster images don't work for CNC-based projects because it's the type of image that most people have the most experience with. So let's now talk about vector images and how they work for CNC, laser, plasma, and vinyl cutting projects. As opposed to photographs, vector graphics are typically logos, line art like cartoons, and diagrams that use strokes, objects, and nodes rather than pixels. It's these lines and objects that all of these machines use to create your final product. To illustrate the point, here's a vector logo from an old t-shirt zoomed all the way out so that you can see the entire image. And no matter how far you zoom into that vector image, the lines stay sharp and clearly defined. This is the eye of the turtle, just as clear and crisp zoomed in as it is zoomed out. This doesn't mean that vector graphics have to be boring and limited to line art images in 2 colors. Vector graphics can be used to create very complex drawings for print purposes, though these wouldn't necessarily be suitable for using on a vinyl, CNC, laser, plasma, or 3D printing project. Vector images and graphics that are more suitable for production processes are often made, though, of only 1 or 2 colors comprised of some pretty basic lines and shapes. The top 2 images show a vector image of a swim team logo that we saw before that was cut out on white heat treat vinyl on a vinyl cutter and then heat pressed onto a t-shirt. The bottom 2 images show the layout of a set of jigs that can be cut out on the CNC machine. The bottom project could be done by hand, but it would take far longer, and drilling all of those individual holes exactly the same distance apart would not only be difficult, but also ridiculously time-consuming. Many corporate or team logos are originally vector images, so that they can be made as large as necessary without becoming blurry, such as a high school mascot for a sign. Designs can also be more complex, where it takes multiple steps to cut out multiple pieces, which are then glued together as a finished project. Vector images can also be used in very large print graphics on paper or vinyl that can be used as a stencil on cornhole boards, like on the top image. 3-dimensional projects like a bar top arcade unit are drawn in a 3D CAD program, which are also in vector format. Then the 2-dimensional vector drawing of each piece of the unit can be laid flat and cut out individually on a large format CNC machine. Another vector logo, like the knight chess piece above, can be used to engrave on glass on the laser cutter. A different horse image could be used to carve on a sign to put near your front door. To recap, no matter what your project is, vector images are going to use paths, strokes, and nodes, while raster images are made up of pixels. Vector file formats are different than raster file formats. Some of the programs you could use for vector drawing as a hobbyist, in order of cost from most to least, are Adobe Illustrator, Corel Draw, Inkscape, and Fusion 360, just to name a few. For raster images, you'll use programs like Adobe Photoshop, Microsoft Paint, or GIMP. Vector drawings won't pixelate no matter how far you zoom in, but they don't work for photographs or photorealistic images. Raster images will pixelate as you zoom in or the image size is increased, but are designed for photographs and images that need to look realistic. Next up, we're going to show you how to use vector images in your projects. First off, each type of tool that you draw for may require a slightly different drawing style, but they are all still vector images. And the good thing about vector images is that changing the style to match the tool is usually pretty straightforward. So let's start with the image on screen of a stylized horse and the number 40, which was used to create a sign next to a front door. Each tool usually has different software that actually runs the machine and that you import your vector graphics into. If you load the horse image from the previous slide into the vinyl cutter software, the cutter will cut whatever color vinyl you load in the machine. In other words, the color of your actual graphic doesn't really matter. There are not a lot of settings on a vinyl cutter, so once you load your image in the software and load your vinyl in the machine, you'll usually just hit cut and go. If you load the same image into Vcarve, in order to set it up for CNC, it will appear as an outline, but then you need to choose what kind of cut you want, how deep it should be, and what kind of cutter you're going to use. So even with the same base image, there are lots of different ways you can make your project look depending on your settings. And if you have sent the red graphic to the laser cutter software, the software on standard settings would have no idea what to do with it. For a little more detail, vinyl cutter software usually sees both the outline strokes and the fill colors in your imported vector drawings. The original color is shown, but only the strokes really matter because that's where the machine will cut whatever color vinyl you actually loaded into the machine. In Vcarve, which many people at Makersmiths use for CNC projects, the software recognizes the stroke or outline of the shapes in your vector drawing and doesn't care what color fill you actually used. And then you set up toolpaths, which are basically what you want to do with each stroke or shape. You might want to remove all material inside a shape, or just cut a groove on the line of a shape. This is an example of CAM, or computer-aided manufacturing, where you're using software to generate the code that tells the CNC machine how fast and where to cut. The ULS program on the laser cutter is a little bit different again. With the laser, the line color and thickness matter because the software interprets different colors as instructions to do different actions with the laser. With the standard settings on our laser, red lines are for cutting all the way through the material, blue lines are for engraving on the line that you drew, and black lines and shapes are for raster engraving. Here is a sign made using the same vector image of a horse from earlier. The order of operations was to first create the image in Inkscape, import it into Vcarve, create toolpaths in Vcarve, then cut the project out on the big red CNC machine. I've also engraved this on glass using the laser cutter and cut it out of heat treat vinyl and applied it to a t-shirt, all using the same original vector drawing.